right, let's talk about compound interest and how to evaluate it. Compound interest, here first of all, we are going to write the formula. You don't have to have this formula memorized, but you have to know how to use the formula. So here's our formula. FV just stands for full value. That just means the full value that's in your account or however much you have after compound interest. Sometimes instead of FV, you'll just see A for amount. Either one is fine. I generally use A, but that's okay. Equals P times 1 plus R, which is your rate, divided by N, which is how many times your money is compounded, to the N times T power. So that's step one. Step one is just write out this formula. Don't skip this step. If you skip this step, you're probably going to get some things wrong in your formula. Just write out the formula. Step two, you're going to identify and write down what each variable equals in your problem. Here are some things to remember. Your rate has to be written as a decimal. So if I have, let's see, 7%, my rate, my R would be, I convert 7% into a decimal, it would be 0.07, all right? Your time must be written in years. So if it gives you 6 months, you would have to convert that to half of a year in order for this formula to work. N, again, the number of times your money is compounded per year. So here are some keywords to look for. These are ones that you'll see. If it's compounded annually, that just means it's compounded 1 time per year. So N means 1. If it's compounded semi-annually, that means it's compounded 2 times a year. So N equals 2. Compounded quarterly means compounded 4 times a year. N equals 4. Compounded monthly would be awesome. That means it's compounded every month, so N equals 12. And those are the ones that you're going to see the most often. Step 3, you're going to plug in your variable amounts right into your formula. Okay, so just plug them on in. And then step 4, you're going to solve. Just make sure you use correct order of operations. And let's go ahead and do a problem together. When you're doing this, and it depends on your problem, you're obviously going to be using a calculator for this problem. Try to keep the whole value in your calculator as much as possible, because if you round and then you use that rounded value to round again, you're just going to be off. So here we go. Let's go over this example. You have it written out for you. Mrs. Gruber deposits $10,000 in the bank. Oh, that would be so wonderful. I deposit $10,000 in a bank at a rate of 7% compounded quarterly. How much will be in my account after 5 years? So I need to, step 1, I want to go ahead, here's my formula, but I want to identify what the parts of my formula are. P, that's my principal. That's how much I am investing or am I putting in the bank at the beginning. That's $10,000. Woohoo! R is my percent, 7%, but I'm going to write it as a decimal. N, it's compounded quarterly, so N is 4. And T, my time, I'm leaving it in the bank for 5 years, so T is 5. All right, so here is my compound interest formula. I'm going to write that down first. Now, again, different people use different number letters here. I don't know why they use S for your amount. I just write A for the amount, but it just means how much you have in your compound interest. All right, so principal times 1 plus R over N to the NT power. So here's my step. I'm going to plug in what I know. Principal is 10,000. 1 just stays as 1. R is 0.07. N is 4. N times T is 4 times 5. Okay. This is the same thing. I don't know why they put that there twice, but they did. That is also the same thing. I don't know why they put that there thrisely, but that's okay. All right, now we're going to go ahead. And again, on my calculator, this is what I am typing into my calculator. Again, I'm going to start with what's inside my parentheses, and I'm going to do this fraction first. So I just go 0.07 divided by 4. Oh, that. I want to add 1 to it because it's 1 plus this amount, so I'm just going to go plus 1. There we go. So that's where we get this 10,000 times 1.0175 to the 20th power, because 4 times 5 is 20. Now, I have to do exponents before I do multiplication. So I'm going to take this to the 20th power. I'm going to use this little hat symbol right here on my calculator. That's the to the power. So to the 20th power. There we go. Ooh, now look at this big long number here. 1.4147 blah, 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 blah. I am not going to clear this. I'm going to keep this whole amount in my calculator. And then I'm going to multiply that by 10,000. 10,000. There we go. And $14,147, and we're going to round again to the nearest cent because we're talking about money, 78 cents. Okay, now let's go back and see what would happen. What would happen if I rounded too soon? So I'm going to go back to this 1.0175, and let's say, and I take it to the 20th power. And I get this funky thing here. And let's say I just go, I'm just going to use 1.41. I'm just going to round it to the nearest hundredth. So I take 1.41 and I multiply that by 10,000. Let's see what happens there. Oh, 14,100 versus 14,147. So if you're rounding and then you take that rounded number and put that in, you're going to be off. And how much you're off depends on how much you round by. So just keep your full value in your calculator and you'll be good to go. And that is how you use compound interest.